Hey guys, so this is the second part for Algebra 2, and basically what I'm going to be covering through this is we're going to be going into solving now. So we're going to take an expression or a formula or an equation, and we're going to find out how we actually solve them and what different kind of methods we use. So yeah, we're going to jump right into it. The first thing I'm going to be starting with is solving linear equations. Okay, so in algebra, linear equations is basically an equation that will form a line on a graph. So if we have a look at this, we're going to say ax plus b is equal to 0. That basically represents that this is in a linear equation and there is only one variable, so it makes it a lot simpler to solve. So it's going to be x is equal to minus b over a. That would be how you would look at how you find x if your answer is basically 0. Not x as the answer 0, but the answer is in when you have the linear equation, blah blah blah. Anyways, so I would definitely remember this. X is equal to minus b over a, because this is going to come in really handy when we're going into area, when we're going into calculus, when we're going into all those kind of different sections where you're going to need to know this. So I would definitely 100% recommend knowing that. Okay, so there are 4 ways that you can try solve this. The first one, when I said from the first video, I think it was the first video, or was it? I can't remember. But anyways, so the first method you can use is trial and error. So I'm just going to write it here. When it decides, trial and error. And so basically what trial and error is basically that you are taking your equation and you're going to take a whole lot of numbers and you're just going to keep putting them in individually into your variable, and you're going to see if it comes out with the answer that you want. So let's just say 2x plus 4 is equal to 12. So basically what you would do with this is take, okay, let's just say 0, 1, 2, 3, 4, and 5. Of course, 1, 2, 3, 4, and 5. So you're going to put 1 in first. So it's going to be 2 plus 4, that's 6. That does not equal 12. Now you're going to put in 2. So it's 2 by 2 plus 4. That's 4 plus 4, and that's 8. So that's wrong. Then you put in 3, and so 2 by 3 is 6, plus 4 is 10, that's not 12. Now you put in the 4, 2 by 4 is 8, plus 4 is 12. And that's how you would get that. But I really don't recommend it because it's time wasting if you have a massive equation with a massive answer for x and you're trying to find that out. It's just too long. Okay. So now the next one is going to be graphs. So basically what algebra is basically points on planes. So you have your x plane and your y plane. So I'm just going to draw them in really quickly. So your y plane is going to be your vertical. So it's this one here. And your x is going to be your horizontal one, like this. Okay, so if you want to try find a point on a line, basically, what you can do is you can, so let's just say y is equal to 2x plus 4. So the best thing to do is try and find their intercepts. So the y-intercept and the x-intercept. This is basically where the line will cut through the x-plane or the y-plane. So what you do in this scenario is you're going to say, okay, y is equal to 0. So you're going to try to find the point on the plane that lies directly on the x-plane, where y, it's not going to have any height, I guess. So y is going to be 0. So if you put 0 in there, draw 0 in there, and then you have 2x plus 4, and then you just manipulate it and all, and you'll find out that it will cross at at minus 2. So it's going to be around here. But I was still on rubber. So it's going to be at minus 2 here. Okay, so now you want to try find where it is on the y-plane, directly on the y-plane, where it has no, I'm going to say length, where x is 0. So you're going to put 0 into the x. I'm not going to write it out, but you put 0 in the x. When you multiply 2 by 0, that's just 0. So you're left with y is equal to 4. So now that's going to go onto your plane 4. and you draw a line. I tried. But what this represents is basically the line that your equation represents. So that would be how you do that. What you could do is, if you want to find a specific point, actually no, that goes on in any other chapters. So just for now, you just need to know that. So now we're going to go on to using algebra. So, where is it, algebra? It is. So, when you're using algebra, it is a lot more accurate and it's a better approach to finding your answers. So, let's just say, I'm going to give a hard one. 3 or a minus 6 plus 25. A plus 2 is equal to a minus 4. Okay, so basically what you would do here is, okay, you see that you have 3 outside of the 4a minus 6, and you have the 25 outside of the a plus 2. So what you would do is just multiply them back in. So you would have 12a minus 18 plus 25a plus 50 is equal to a minus 4. What you are going to do next is you're going to take away a minus 4 on this side, take it on the side where a minus 4 is, and you're going to take it away on the other side where the 12a minus 18 and all that is. This basically means that we are going to basically bring it over, but we want to do it in a way that is much more mathematical than just bringing it over. So it makes sense to take them away. Hang on. So minus a plus 4, I'll get rid of it. Minus a plus 4. Now we just want to look at this. So 12a minus a is 11a, 25a is 36a. Minus 18 plus 50 is 32, plus 4 is 36, equals 0. And if you want to dumb this down a little bit more, a is equal to, or no, not that. A plus 1 is equal to 0, because the variable and the constant has 36, so you can basically just divide it by 36. And you can do it on the other side as well, it just means that it's always going to be 0. So then you have a is minus 1. And that is a lot simpler than using graphs or trial and error. Algebra 1, the algebra approach is the best accuracy, and you will find a lot of answers easier through that method. So I'm just going to see, is there any more methods that I need to use? There are not. So now I'm going to move on. And now we're going to go into simultaneous equations, because that is actually another method. So what simultaneous equations are is you're taking two equations, and basically what you're doing is you're trying to make one big equation out of factorizing and cancelling out to see what's alike in both of them that will represent. So you're trying to make a new line that will represent both of the other lines, basically. So just say 2x minus 6y equal to 24, 5x plus 6y is equal to so I'm going to put 14 for the 2x minus 6, and then 56, this one. So as you can see here, you have different equations, but they have the same variables. So what we're moving on to now is solving in two variables. The first one, we're solving in linear equations with just one variable. Now we're going to move on to two variables. On one of the examples I did give y equals blah blah blah, but this is when two variables are on the same side. So that's the difference. So even though you can manipulate it, but whatever. So we're going to move on, and what we're going to try to find first is what's common in both of the equations. Okay, so obviously there is an x and there is a y, but in the solution side where the 14 and the 56 is, there are no variables, so you cannot divide them. What you can do is you can say, okay, we can add the two equations together, and we can. This is where the cancelling out comes in, because if you look at both of the equations, one of them has a minus 6, and the other one has a minus 6y, and the other one has a plus 6y. And what happens in this case is you say bye-bye, because that's going to equate to 0, and use the other two conditions, or terms. So now this is going to be 20, so x is going to be 10. Okay, so now we're going to take one of these equations. I would recommend using the one with the smallest solution. So the 2x minus 6y is 14. That has, well, obviously 14 is smaller than 56, so obviously take that. So we're going to say 2x minus 6y is equal to 14. What you're going to do is you're going to sub in your 10. You're going to write it like this. And so you know it's 20 minus 6y is equal to 14. Take 20 away from both sides. And what you're left with is going to be minus 6y is equal to minus 6. So basically you can cancel out the two minus signs. What I'll show you is just do that, because they both contain the minus sign, so it makes sense to just get rid of it. Now what you do is divide both sides by 6, and you're going to have 1. So that is basically how you would do simultaneous equations with two variables. When you're using two variables in terms of graphs, basically the same thing as I showed you. Let them 0, find out their intercepts, and just, if you want to take two equations and find out where they intersect, you just do it with both equations. What you do at the end is simply just draw the lines on your graph and see where they cross. That is where your intersection is. So now I'm going to go on to simultaneous equations in 3 variables. So this is now where we introduce the z component. So space and all that, we can't necessarily see planes. Well, obviously we can see the real planes, the ones that fly us everywhere, but in terms of the planes that contained in algebra, we can't see them. So there's an x plane, a y plane, but now there's a z plane. This is where we say that it is the third dimensional. In the third dimension, because now you're going to have basically width by height. If you remember all of that knowledge from primary school about area and cubes and volumes and all that, this is basically where you see that when you have 3 planes, it is 3D. When you have 2 planes, it is 2D. If you go on to do in college, you're going to learn that you would call these R2 and R3 because it's in the D plane or the 3D plane, and so on and so on. Anyways, so let's get back to business. So say here have a pen. So this is going to be your Z plane, going to be your Y plane, be your X plane. So what you want is to find a point that is in all 3 planes. So it corresponds with this one. So you can see there that that is a point. Get rid of these dotted lines. I honestly don't know why I did them. Don't draw that again. Oh, no. So basically that is a point in all 3 planes. I want to see where it intersects the Y plane, where it intercepts the Z plane, and where it intercepts the X plane. So what you would say is, get rid of this because you don't need it anymore. An equation would look something like this. So then you could have a second equation. So let's just say, but because it's 3 variables, 2 equations is not going to cut it. Because let's just say you do cancel your 2z. Let's just say you cancel your z. What you do is you'd multiply the top equation by 2 to be able to cancel out the z's, but you're left with your x plus y is equal to 6 and 5x plus 3y is equal to 5. And you wouldn't be able to, well, I'd say you could, but, you know, easier to introduce just a third equation because it makes it all look much more professional and it is easier. Let's just say this equal to minus 8 times, I swear. So bring this down and I'll look at your equations. So is there anything we can cancel out straight away? Yes. Can cancel out excuse me. Can cancel out the so you can take your equation 1, equation 3, the one is going to be equation 2, and basically what you are going to do is you're going to you're going to multiply either one of them by minus 1. Doesn't really matter which one you choose. I think it's easier to just take equation 1. So minus x y minus z is equal to 6 minus 6 x minus 7y z equal to minus 8. Cancel out your z's. So what you're going to have is 2x minus 8y is equal to minus 14. So is one equation that you have. What we'll do next is try and find a second equation. So let's take, and you're going to be cancelling out z again. So let's take 1 and 2. So we're just going to have a look at it quickly. So we need to multiply the top row by 2 to make it plus 2z, so the plus 2z and the minus 2z cancels. So x 2y z is equal to 6. Second equation there is 5x plus 3y minus 2z is equal to, so let's just write that in there. I don't want help. See, I want help, but not right now. So it's going to be 5x plus 3y minus 2z equal to, okay, so now you can cancel out your z's because they're both the same, they're both equal but opposite. You do the on the others, so you say 7x plus 5y equal to 11. So just scroll back up here quickly. What you have done is you have created 2 more. So 1, 2, this will represent 4, and the other one right here, that's equation 5. So what you're going to do now is you're going to take those two and try find one equation. So it's going to be x minus 8y is equal to minus 14. 7x plus 5y equal to, and I want to just check that I've written everything correctly. Yes, I have. So now I can just keep going on. So I'm going to try find something that will cancel out either the x or the y. My preference would be to cancel out the, just because they'll make smaller numbers. So multiply the top one by 7, bottom one by minus 2. Take out the x's. So a x minus 6y equal to 14 squared, that's 196. So minus, now the bottom one by minus 2 is going to be minus 14x minus 10y going to be minus 22. What you do is you cancel your x's down of minus 66y to 174. So you can just get your calculator out, say 4 divided by 66 to get your y. Okay, I've done something wrong. Let me have a look. What did I do wrong? Oh, okay, I see where I went wrong. This should be plus 56y. We should have, so where plus there? I don't see where I went wrong yet. I forgot to multiply the 6 by 2. So this is actually going to be my bad. So I'm just going to look at the first one just in case I made a mistake somewhere. Oh, I didn't make a mistake there. So let's just see. Go. No, this should be. Now we're going to get a different number. And again, it should be 34. Now I'm back on track. Okay. So now we need to get rid of this 6, and we're going to say 4. 46y. 174, it's wrong. And now the answer is 162. just write it in here. And now we just need to double check that that is going to be correct. What am I doing? No, that's still my bad. Much on track this morning, and now I have basically disintegrated. So now it's that, and this now should be correct. Hang on. So 7, isn't it? What am I doing? Instead of the 196, it should be 98. That is where I went wrong. Mistakes. I just didn't like how I made that mistake. So now we're going to scroll down and correct now. It's going to be minus. The answer is going to be 132. 66y is equal to 132 is equal to 2. Always keep checking your maths, because you will mistake somewhere to pick up on it. Everyone make the mistake throughout their lifetime. Excuse me. So now I'm going to take, so now we know what y is. So you can take either one of equation 4 or 5. I'm going to take the easier one. So what I'm going to say should be minus 8y is equal to minus 14. Y is, so we're just going to say 2x is equal to, say, minus 14 is equal to 2x is equal to 1. Now you have your do is you try to find out your z value, so you bring both your y and your x value, try up to original 3 equations, and try find an answer. First, the easiest thing to do is to use the first equation, because it all has the same coefficient of 1, small solution 6, so we're going to take that, plus y plus z is equal to 6, plus 2 plus is equal to 6 will be 3. Plus 1 plus 2 is 3. You take 3 away from both sides, so you z is equal to 3. Or 6 minus 3, which is 3. So, what's the next one? Is very important. So, I'm going to find something else here. I'm all good. So, the next one is simultaneous equations, where you have that is a linear and another one that is a nonlinear. So let's just say you have that is x plus 4y 1. 2x squared plus 3xy is equal to. The first that you would want to do is not going to follow the same rules as the other two. What you can do is you can try get some expression for x, and you can your second value or equation. So it's going to be 1 minus 4y. So you just take your second equation, squared plus 3xy is 35. What x is now. So it is 2 minus 4y squared, 3 minus 4y is equal to 35. When it decides to draw, stupid thing. So it's going to be 35. And basically what you can do now is you can actually factorize, because you have one that is similar to the two squares, and it's going to look very so now is 4y the the sum of two squares, or whatever, the two squares basically, minus sign in it, then it means that one of the expressions is a plus and one of them is a minus, so that is why that is. So now you have plus 3 y 35. So you have this. Now is you're going to, what you do now is basically multiply out your 2, or no, what am I doing? One wrong, and I'm going to tell you why now. I have 4y squared. That's not saying that that's not the same form as the 2 squares. What I'm saying is that this expression will be squared. So that is why I corrected my mistake. So you can multiply the two expressions of the 1 minus 4y. 2, 1 minus 8y 16y squared plus 3 minus 4 squared. It's simpler to just do that straight away so you don't have to worry about it later. Equal to 35. So now what you want to do is you want to basically single this down to single it down to one whole like for y. So now we're going to say 32y squared 16 plus no minus, we're going to always try to put the squared terms for the non-square terms. So it's going to be minus 12 squared plus 3y 35 0. Always try have your equations equal to 0. It makes it a lot easier to solve. So you're using the origin, because basically the quadratic will do, it'll form a, so you know that the is going to be the origin, so that's why you would use 0. Now you just do the simple math, so now it is 20y squared 13y minus 3 0. Here's that 33 and 2, that makes minus 13 out of the 20y, so use the minus 10. So basically, so what now is the 33 and the 1, because if you add the or the 33, it's going to be 33 by 1. If you by 1 by the 20, that's going to be add on to the minus 3, that's going to give minus 13. So do this, so 33 plus 1, find its roots, that in the next one, so it's going to be minus 33 all over 3 is equal to n. So now is you're going to take your two possible answers and back in your x. So if you remember, x is equal to 1 minus 4y. Take the 33 over 20. 33 over 20 by 33 over 20, which will equal minus 3 over 5 minus 28. So now you have that answer. Use for finding out when you use minus 1. So x to 1 minus 4, which will equal 5. I like this answer better than this one. Fractions are not nice to look at, but it's much better than decimals. I always try use decimals, or fractions rather than decimals. So now what you're going to have is you're going to have 2 points, and those 2 points are going to be minus 28 over 5 and 33 all over 20, or 5 and minus 1. So those are the 2 points that you can have on in your plane that can represent the two equations when they're basically mashed together. So that would be how you would do that. I'm going to bring this up. So I'm going to jump into this one first. I was going to do this after the factor theorem, but I think it makes a lot more sense to do it now, because what I'm about to show you, so basically when I did the one linear and one non-linear simultaneous equations, basically with the quadratic equation, I basically just did it in my head. But if you are someone that doesn't know how to do that in their head, this is the equation that you can use. So just get rid of that. X is equal to minus b plus or minus root b squared minus 4ac all over 2a. Now, you can use this if you don't know the two roots. It's just going to take you a little longer than finding it out in your head. You can use the square method, but I don't have that method, so I'm not going to use that. Excuse me. So we're going to find out now we're going to have a look at this. So when you have your form ax squared minus bx plus c is equal to 0, you can see that the a will obviously correspond with the a in the equation. The minus b will be the minus b that is in the equation. Excuse me. And the c is going to be the c that is in the equation. So anything that is in this general form, their coefficients and the constant, is going to be exactly the same as the letters that are in this equation. So, or this general formula, not equation. So please remember this rule. Okay, so I could do an example, but I think you've got it. And just remember that if you have a minus sign in the square root sign, you're wrong. I'm not going to explain why, it's just wrong. And you will find that out actually in when you do complex numbers. I think I did it in 6th year or late 5th year, I can't remember when I did it, but complex numbers, that is when you look into when you have the square root of a negative, but you'll look into that a lot later. So that would be how you would solve it. And it's also used to solve when you actually cannot use the doing it in your head. So let's just give an example. Okay, let's find one example. If I can find an example. Okay, let's try 3x squared minus 2x minus 23. So obviously, as you know, that 23 is a prime number. Prime numbers are basically where you multiply a prime number is where a number cannot be multiplied by any other number. It can only be multiplied by itself and 1. So 23 is a prime number. So that is the perfect example. 3x squared minus 2x minus 23. So you can multiply the 1 by 3, but it's not going to give minus 2. Nothing will give minus 2. So that is the perfect example of when you use this formula. I'm not going to do it now, but that is basically how you do that. So now we're going to go on to the factor theorem. So exactly what is the factor theorem? So the factor theorem is basically finding out obviously factors in a polynomial function. So what you're using here is basically say, actually I'm just going to give you the form. So you have function, and it's going to be, let's just say, a to the n x n. This means that it is the nth coefficient plus a n minus 1 to the x n minus 1 plus dot 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 a to the 2x squared plus a 1 to the a1 to the x plus a to the 0. So that would be the factor theorem. And what this is basically trying to solve is what is a root. The factor theorem is when you're using this form and you're taking an equation and you're trying to find out, okay, is this number a root in this equation? So I'm going to look at an example. So let's just say f of x equal to 2x minus 3x squared minus 17x plus 30, and that's going to equal to 0. So why I included the f of x, I didn't need to. So we're going to have a look at 4 numbers, 1 and minus 1 and 3 and minus 3. Excuse me. So we're going to sub 1 in first. So it's going to be 2 minus 3 minus 17 plus 30 is equal to 0. Or don't need to write in the equals to 0. So you just look at this and you say, okay, 17 plus 30 is 13. Okay, we're 13 away from getting the right answer. But 2 minus 3 is minus 1. So it's minus 14. Or is it? No, it's 12. It's 12. My apologies. So that's wrong. So we're going to say root does not equal 1 or minus 1. If you put minus 1 in, you're just going to get everything inverted, and it's still not going to be right, so there's no point in doing that. So what you're going to do next is you're going to put 3 in. So you're going to have 3 cubed, which is 27. So it's 54 minus 3 by 9 is 27. Minus 17 by 3 is 51 plus 30. I think we're fairly close. 54 minus 27 is 7. Minus 51 plus 30 is minus 21. So, am I saying 54 minus 27 is not just 7. It is 24. 27, Jesus. Sorry. So we're going to say 27. That's going to be minus 21, and that's 6. So unfortunately, minus 3 is also not a root, or 3 isn't a root. And you would think that minus 3 is going to be the same. No, it might not be. And with the minus 1, I just knew, because with the x cubed, it's going to turn the 2 into a minus 2. So that wouldn't have made a huge difference. With the minus 3, it could, because 27 is a bigger number than 3. So let's try it. So we're going to have minus 54 minus 27 plus 51 plus 30. Okay, so 51 and 30 is 81. Minus 54 minus 27 is 81. Minus 81 is 0. So root is 3. And that would be how you would do that. Formula manipulation next. So just try and find that. Another thing I might say is, if polynomials have the same root, then, kudos. But they would differ is in their actual equation. So let's just say y is equal to 3x cubed minus 21x plus 18. Y is equal to 2x cubed minus 14x plus 12. So, sorry. So it says here that the roots are going to be x is equal to minus 3, 1, and 2. So those two equations are going to have the same roots, but because there is the different coefficients, so now I'm going to go on to formula manipulation. So what we mean by a formula manipulation is that we're taking a formula and we're trying to make it so that we can have a different part of the equation equal to everything else. So what we can say is, I'm going to take an example for volume. We know that v is equal to pi or squared h. Let's just say that we want or on its own. So what we would do is we would divide this by pi h, because it's not necessary anymore. So we divide both sides by it, and so that will mean that v over pi h is equal to or squared. We're almost there, so we want the squared gone. So what we do is we square root each of them. So what we have left is or equal to root b all over pi h. Even if you wanted to get h on its own, you'd divide by pi squared, and you don't need the square root, so you could say h is equal to v over pi or squared, and that's basically formula manipulation. So let's just take a is equal to root p over minus q. Let's say that you want q on its own. So what you would do is, you would say, first of all, you have a root sign in the way. So how you do that is you just square both sides. That gets rid of that root. So you have a squared is equal to p all over 1 minus q. And now you're going to isolate p for a while. So actually, if you wanted to know p, you could say p is equal to a squared minus q. And we want to know q. So we're going to have here p equals a squared 1 minus q. What we are going to do is we are going to say p all over a squared is equal to 1 minus, I don't need the bracket anymore actually, 1 minus q. And so q will be p all over a squared plus, because you would have p over a squared minus 1 is minus q. So now you're going to have q is equal to, I'm going to make it sound nice, 1 minus p over a squared. So that's basically how you do formula manipulation. And the last thing that I want to cover is how you would use algebra in problem solving. when you're problem solving, let's just say you want to find out something with temperature. You're not going to be given X or Y. You might given, okay, C as in the temperature, F as in the Fahrenheit temperature, so let's say F is Fahrenheit, the Celsius is C, and you have your constant 32, which basically means that it's changing. And what you want to find is basically, actually I'm not going to use that example. Anyways, you would have an equation. It wouldn't be an X and Y one sometimes, but you'd basically be given numbers, or you'd be given facts, and you need to read every single word, every single thing they're saying, look at the formula or the equation, see what you can do with it. So let's just say with the temperature one, the relationship between degrees Fahrenheit and degrees Celsius is given by the formula is equal to 9 over 5c plus 32. The first question is, at what temperature will degrees Fahrenheit and degrees Celsius be the same? So what this is what they've said already is the relationship. So that means that they're telling us that Fahrenheit and Celsius are linked in some way, and they've given us a formula. Okay, this is a nice easy one. Carl and Eddie's ages together to make 65. Stop. Now you know we're going to say I equal to 65. 10 years ago, Carl was twice as old as Eddie. So what that means is that, let's just say, so 10 years ago, we're going to say y plus 10 is equal to 65. So again, we're looking at this and we're trying to say, okay, it was 10 years ago, so how are you going to write something that will basically represent that? So you want to say that Carl's age is X. No, Eddie's age is X. So Carl's age is 2X. So what we're going to say is y plus 10 is equal to 2x plus x, or something similar to that. So we're going to write that down and see if it works. Y plus 10, no, y is equal to 2x plus x. Or I can just say 2x. I don't need to say, or do I? If he's twice as old as Eddie, then you're adding on that with that, yeah, probably would, plus x. So y is equal to 3x. And let's just say y plus 10 is equal to, so now you have y is equal to 3x. So you know that y plus 10 is 65. So we're going to say, so when you bring it back 10 years, then it's going to be obviously it would actually be 20, wouldn't it? So 45. So now you can say x is 15 and 2x is 30. And this makes sense because 30 is double than 15. When you add 10 on each of them, you would have 50 and 25. Oh wait, no, it's 40 and 25. So that's 65. So yeah, that is how you do that. It would be nice and simple. So you would say, you would give your equation. You know that y plus 20 is 65, so you have that equation, or y plus 20 is equal to 65. So you just take them away and you know that y is 45. So now you just take this formula back, this one here, and you find out what x is. So that's all you really need from that. So we're gonna write this here. So you have x and x. Okay. So that's Algebra 2 done, part 1 and 2. So thanks guys for watching, if anyone has watched. So I'm going to be looking at Algebra 3, and that's going to go more into depth into such things as inequalities, or using the modulus notation and all those kind of things, but that'll be for tomorrow's video. So I will leave now and say thanks and goodbye. So tune in next time.